Okay, so what we're going to do in this video is we're going to look at how to work out the arc lengths and the areas of sectors and segments for circles. Okay, now let's look at the first example. We're going to look at the arc length of a circle. Okay, now the first question that you might ask is, what is an arc length? Okay, and an arc length is simply just a piece of the circumference. Okay, so the circumference is the full distance around the circle, like this. Okay, that's the circumference. And then the arc length is simply just a little piece of that. Okay, so it's a fraction of the whole circumference. Okay, now that's shown on the diagram here as this distance from there, this point to this point, and we're going to give it the letter L. Okay, arc length. Now to calculate the arc length, okay, we know that it's a fraction of the circumference, and the circumference is given by pi d, okay, or 2 pi r. Okay, now we're going to use 2 pi r because it makes more sense for this diagram because we have it in terms of the radius here. Okay, so what we're going to do is we're going to use the angle that this arc occupies for the whole circle to figure out what the arc length here is. Okay, so the equation that we're going to use is the arc length, so L, is equal to the circumference times by the angle at the centre as a fraction of 360. Okay, now the reason why it's 360 is because a full turn is going to be 360 degrees. Okay, 360 degrees, and that this angle here is a fraction of the whole circle's angle, okay, which is why we're going to use the theta, the angle at the centre, out of the full angle of a circle. Okay, so if the arc length is equal to the circumference times by theta divided by 360, we can replace the circumference here with 2 pi r. Okay, so the length is equal to 2 pi r times by theta out of 360. Okay, now let's try this as an example with some numbers. So I'm just going to tidy this up slightly. So the equation that we're using is L for arc length is equal to 2 pi r times by theta divided by 360. Okay, so we need to know what the radius is, we need to know what theta is. Okay, so I'm going to say that the radius is 5 centimetres. Okay, so this distance here is 5 centimetres, okay, which also means that this one is 5 centimetres. Okay, and we're going to say that the angle at the centre is 60 degrees. Okay, so what we're going to do is we're going to substitute in these numbers to this equation. So the arc length is equal to 2 pi times by the radius, which is 5, times by theta, which is 60, divided by 360. Okay, now what we're going to do is we're going to figure out what this is as a simpler fraction. So we use our calculators to do 60 divided by 360. We get a sixth. Okay, so L is equal to, we're going to do 2 times 5, which is 10. Okay, times by a sixth, so that's 10 sixths pi centimetres. Okay, now this answer is what we call expressed in terms of pi. Okay, so that means we leave pi as pi. We don't work the answer out as a decimal. Okay, now if you're asked to work it out as a decimal, then what you need to do is you need to type in 10 sixths pi into your calculator, and then you need to find the SD button on your calculator. Okay, so if you have a Casio, this is just above the DEL symbol, so the orange delete button, and then what you will get is you will get that the length is equal to 5.23598 ... centimetres. Okay, so let's say for example we were asked to give this to one decimal place, we would round it to 5.2 centimetres. Okay, and then always specify what degree of accuracy you've given your answer to, so 1 decimal place. Okay, so that's how you find the arc length. Okay, so we take the circumference equation and we multiply it by the fraction that the angle takes up of the whole circle. Okay, so next one, we're going to look at the area of a sector. Okay, now this is slightly confusing because if you think of an orange, okay, because we talk about sectors and segments here, you might refer to a piece of orange that resembles this part of the circle here as a segment. But when we're talking about circles, this part here is actually called a sector, okay, and a segment is slightly different. So if we just have a quick look at what a segment actually is in mathematics, it's whenever you have a line that joins the two end parts of the sector together, like this. So this is actually a segment when we're talking about maths, okay. So that's one little thing that might be slightly confusing just to bear in mind, okay. So we're going to go back to the area of a sector here, okay, and it's very similar to working out the arc length of a circle, okay, but instead it's with the area. So what we do is we look at the area equation for a full circle, which is pi times the radius squared, and then we say, well, the area that is being occupied here is just a fraction of the area of the whole circle, and the fraction that is again theta out of 360. Okay, so it's the fraction that this angle occupies of the full turn of the circle. Okay, so let's try this with an example again. So let's say our radius is 5 centimeters. 5 centimeters. We would substitute r is equal to 5 into our equation, and again let's say we have an angle of 60 degrees. Okay, so the area is equal to pi times by the radius, which is 5 squared, times by 60 out of 360. Okay, now again we do 5 squared, which is 25, and then 60 divided by 360 is a sixth, so 25 out of 6 times by pi, and this is going to be centimetres squared. And again, if we are asked to leave our answer in terms of pi, this answer here is perfectly fine, okay? But if we're asked to give it to, say, 1 decimal place or 2 decimal place or a number of significant figures, then we need to type in 25 over 6 times by pi into our calculators, and then we will look for the SD button again, and then what we should get when we press that button is A is equal to 13.08996 ... centimetres squared. Okay, so if we're asked to round it to 1 decimal place again, we would get area is equal to 13.1 centimetres squared. Okay, and that's how you work out the area of a sector. Okay,